Okay, so task 2, learning-based strategy. Okay, so Cody has a great breakdown and plan for this task. So let's see. Yeah, so basically Cody wanted to, so his team wanted to train the regression model using this data set, on this data. So this is actually, so the predictions for, of each individual weak defenses on each example here. And then with the corresponding labels here. But I doubt it here. I don't think you should use the, you should train this strategy model, regression model on the test data, because you should not see the test data at the training phase. So you might want to train your model on the training day. What did I say? Yeah, you should not use the test set to train your model, because the test set should be unknown, should remain unknown until the inference time. So you need to train this model using the training data. But if you want to use the AEs to train the model, if you want to do something, if you want to do that, I would suggest you to separate. For example, right now we have 10K test set, 10K test data in the test set, right? 10K samples. So I would suggest you to sample, for example, you will use, I'm not sure. I just make up some numbers here. For example, you will separate this these AEs into 2 separate data sets. So for example, 6K for the training, or 8K for the training, and you need to keep the rest 2Ks unseen for until the test time. So you will train your model on the 8K AEs, and then use the rest 2K AEs to test the model. Because if you train the model and evaluate the model on the same data set, it learned from the data set, so it should perform very well on the same data set when you evaluate on it, right? So if you want to use some AEs to train this model, I would suggest you to separate them into training data and test data. Okay, I just, yeah, that's some suggestion. I just remember. Okay. I think that's a good breakdown. It's a good plan. So I will not provide the a full process for this tutorial, because I would expect to see more exploration from you. I don't want to constrain your ideas of this. Okay, so I will provide some APIs and some of my comments or suggestions that might help in your task. Okay, so actually we provide an API to collect the raw predictions. So this raw prediction is actually a 3D array of the probabilities or the logics that each individual weak defenses made on an input. Okay, so for example, we have a test set consists of 2 inputs, so 2 images here, x1, x2, and then since we are talking about the MNIST, so it will have 10 classes, right? Digital 0, digital 1 through digital 9, so 10 classes. And then we just created an ensemble named ATHENA, and we used 3 weak defenses to build this ATHENA ensemble. Then we can collect the raw predictions on B like this way. So since this is the ensemble, we can call predict API directly. So we call this predict, and we pass the test data, and we set this raw to true. So this function will return you the raw predictions. So this raw predictions is an array of this shape, of the shape of this. So 3 weak defenses, 2 images, and a vector of 10 probabilities for the 10 classes. So I think the only difference of these raw predictions from what you want here is the order of the dimension, right? So you will expect for each image, you get the predictions of the weak defenses, and then in our case is WDs, and then image 1, image 2, image 3, something like that, and WD2, image 1, image 2, image 3, something like that. So all you need to do is when you get the raw prediction, you can apply some transpose to that matrix. Then you will get whatever you want here. You can try on a very small scale to see whether to make sure you transpose the matrix correctly. Okay, so here I also provide a Python tutorial for the usage of this API. So the Python tutorial is in this file, and then if you wanted to collect the raw predictions, you will call this API with raw equals to true. And so here we provide the predictions for raw predictions for probabilities and logics. If you wanted to collect the output from some hidden layers, you need to maybe, I think, major modification will be made in this file, in this Keras wrappers. I just refactor. I changed the name of the original name is Keras.py, because that Keras is duplicated with the package Keras. So I changed the name. I rename it as Keras wrappers. So this will provide a wrapper for Keras models. Okay, so let's start from the very beginning. Import packages, and then here is some demo of collecting the raw predictions. So this function will require the configurations of the transformations of the models and the data, and also a flag, whether to use logics or probabilities. So if it's true, it will return you the logics value. So this logics value are the outputs from the layers before softmax. So if you make it to be false, that was the default value, it will return you the probabilities. So after we apply this softmax on the logics value. Okay, so we need to load the weak defenses. And in this demo, I try with a very small pool that consists of 3 weak defenses. Yeah, so the same as we described in this demo, in that example. So we load the pool of 3 weak defenses, and we will build an ensemble using these 3 weak defenses. Then we will load the data. It can be so this will be the training data you will use to train your strategy model. Okay, in this, so when you load your data, your training data, and so in this demo, again, I will use a very small subset. It will consist of only 2 images here. Okay, then I will collect the raw predictions for this data set. So ATHENA .predict and make this raw to be true. Then I will get the raw predictions on this data set. And then I also do the prediction. So this is the final predictions on the same data set as the, as the comparison. Okay, so we get the functions here. So we get the configurations and then call the functions here. So here we collect the probabilities, because we will because the use logic equals false here. Okay, so it will load the weak defenses and do the prediction. You can see this is the raw predictions we have on that data set. Consists of two samples, and from the ensemble building with 3 weak defenses, and then here we get 10 a vector of 10 probabilities on the 10 classes. Here is the raw predictions we collected, and this is the final prediction on this data set. So basically they are just the probabilities of each samples here. When you apply argmax on these probabilities, you will get the predicted label for the first image and for the second image. Okay, so I just copy the results from this one from above to here, and add more concrete comments here. So you will see, so this raw predictions, we will get the results for the first WD, and then the 2 samples here, the second WD and 2 samples, the third WD, 2 samples, like that, something like that. But I know what you want is, for example, the first input and 3 and the 3 predictions from the 3 weak defenses here. All you need to do is I think you just transpose, switch these 2 dimensions. Yeah, so here is the final prediction, and this is the example to collect the raw predictions of for the logits value. So if you want the model to return you the logits model, when you load the model or load this pool, set this use logits to true. Okay, so as what we did here, the rest will be the same as above. Okay. Now you can see the collected raw predictions will be in the same shape of the probabilities, right? So, but the values, you can see values are different. These are the logits values. Okay, so I think that's pretty much it is. Let me, I'm not sure. Let me give you the example how to transpose this raw predictions into the shape you want here. Okay. Let's do something here. Okay. So we transpose the raw predictions to whatever you want. Okay. So let me call it as the Okay, so this NumPy provide us a transpose function. So you need to pass the arrays you want to transpose and then the new shape. Since we know this is a 3D array and we wanted to swap the first and the second dimension, so you just swap the index here. So we want this to be the new first dimension, and we want to swap 0 and 1 and keep the last one unchanged. So this is the new shape. Okay, let's plot the shape to see if the transposed. We can check whether this is what we want. Okay, we can run this again, then rerun this. Okay. Yeah. So you see here, this is what you get from the API, right? And then you just transpose the raw predictions you collected from our API. So swap this swap the WDs with the examples. So you will get an array. So for the two examples, right? The first example and the second example. And for each example, you will have 3 predictions from the 3 WDs, right? In the ensemble. So I think this is what you want in here. So for this table. And okay, let's try the logic values. So you can see you will get the same, right? Yeah, transposed. Okay, I think that's pretty much it is for the learning-based strategy. Okay, for further questions, you can ask in the you can open issue. I just connected the that project with my Slack, so whenever there is some updates in the repo, I will receive the notification. I will be noticed. So I can I will try to answer your questions as soon as possible.